Hello students, this is the video number 45, Chapter 10, Part A, Induced Magnetism and Neutral Points, Class 9th for subject Physics. In this video, we will discuss about magnetic field of Earth. As you know, directive property of magnetic compass. When we will suspend a magnet, so always it will align itself in one particular direction, that is north and south. So while magnet aligns in north-south direction, the reason is magnetic field of Earth is a magnet, or magnetic field of Earth is always existing, okay, because Earth behaves like a magnet. If we'll talk about few evidences, so there are few evidences. Evidence number 1, a freely suspended magnetic needle always rests in geographic north and south, which I have told you earlier. Second point is an iron rod buried inside the earth along north-south direction becomes a magnet. So that is also a kind of evidence which shows that earth also has magnetic field. Third point is neutral points are obtained on plotting the field lines of a magnet. So neutral points are those points where Earth's horizontal magnetic field and bar magnetic field, they both cancel each other. Means a location where you will not get any magnetic field, not even because of bar magnet or not even because of Earth's magnet. So this is also kind of evidence. Means if Earth's magnetic field is there, then only you will get the neutral points. Fourth one is magnetic needle rests making different angles with the horizontal when suspended at different places of the earth. So it means if magnetic field of earth will exist, then only different angles are possible. Otherwise, same angle you will get on the surface of earth. So this all shows that earth also has magnetism. So with the diagram I will explain to you. Suppose this is a circle representing the Earth's magnetic shape of the earth, and here is the geographic axis. This is the geographic north, and to this side we will have geographic south pole. Okay, and this is the position, right? This is the position. So this is the axis which is passing through these poles, and there is a huge bar magnet. This is assumed to be considered somewhere inside the earth in this way. So magnetic compass, if I'll keep over here, this is the position of the magnetic compass. In this way, so it is pointing towards geographic south, right? And if I'll keep magnetic compass somewhere here in this way, so magnetic compass north will point in this way, and this is the south. But if I'll ask you what will be the polarity of this huge bar magnet, so what will be the polarity over here? This polarity will be of this magnet will be south over here, and this will be north. Okay, so this north is responsible to attract the south towards itself, and this this will be north, and this will be south of magnetic needle. So north is pointing towards north. North is pointing towards north. But as you know, north and north will repel. Okay. But this north is not attracted towards this north. This north is attracted towards south. So this south is responsible to attract north towards itself. So automatically this north will point towards geographic north. If I'll talk about the angle, this angle is 17 degree. So magnetic axis, this is the magnetic axis, and geographic axis, they are not coinciding each other. They are at certain angle, that is 17 degree. Okay, so there is one equator on which you will get the magnetic compass in this way. Means north will come towards north, but actually this north is attracted towards this magnet's south pole. So north is pointing towards north but attracted by this south. So now at this position, if you'll see, the magnetic needle is just coinciding with the horizontal surface, and over here also here also. So magnetic needle is just coinciding with the equator, with the horizontal surface at the equator. This is the equator. And at the poles, it is making an angle 90 degree with the horizontal, and here it is parallel or makes an angle 0 degree with the horizontal. So the two places where the magnetic needle becomes vertical are called magnetic poles. So these are the two key points. One is two places where magnetic needle becomes vertical. These are the two places. So this is the north pole and this is the south pole. This is the magnetic north pole and this is the magnetic south pole. So you can write here, this is the magnetic south pole, and here is the magnetic north pole. So one axis is passing, this is called magnetic axis. So two places where magnetic needle becomes vertical called magnetic poles. Here it is vertical, making an angle 90 degree, and the line joining the places where the magnetic needle becomes horizontal. You can see these are the two places. So the line joining these two places where the magnetic needle becomes parallel or horizontal on the surface, right? So that line is called magnetic equator. Okay. So uniform magnetic field of Earth, how to plot this? At anywhere you can keep magnetic compass will rest in one particular direction, so that will help us to get the north pole when it is moving in this way. Okay, so another direction you will get in the same way. And one more time you can get the direction, because north will point in the same direction. So all these points, number of points I can get in the same manner. All these points, if I'll join, then that will be the direction of the magnetic field line due to Earth's magnetic field. So in this way, parallel magnetic field lines I'll get. Parallel magnetic field lines, what it means? The magnetic field is uniform in nature. And here you'll have geographic north, and to this side you'll have geographic south. Now we can draw for the bar magnet also. Let it be north, here you'll have south. So magnetic field lines always starts from north and end in south in this way. So these are the continuous closed curves. In this way. Here you have north to one side and south to other side. This is north and here you'll have south. Magnetic field line starts from north in this way and ends in south in this way. For the U-shaped magnet, one end will be north and other one will be south in this way. So in this way the magnetic field lines will get always starts from north in this way. It starts from north and ends in south. Starts from north and merge in south. Now when two ends of the magnet, they are facing each other in this way. So magnetic field lines always starts from north and ends in south. So north to south. Suppose if you'll have opposite polarity facing each other. Opposite polarity. So in this way, magnetic field lines will come from north and will be repelled by the magnetic field lines of another north in this way. So direction is again away from north, or you can say it starts from north in this way. So same case you will have for south, but the arrows will be inward. Now here, if we will try to get the magnetic field due to this bar magnet, so suppose this is the point or this is another magnetic field line. So I am interested to get the magnetic field at this point. So arrow is downward. I have to get one tangent to get the magnetic field due to bar magnet. This is B due to bar magnet, and black marker I am going to use to show the magnetic field due to earth. Let it be BH. So now the direction of magnetic field due to the earth and as well as due to the magnetic field due to this bar magnet, they are in opposite direction. So these are the position of the neutral points where the cancellation or these two magnetic field will get cancelled. So to this side also you can get another neutral point position, and always you will get these two neutral points in west-east direction or east-west direction. When it will happen? When the north pole is pointing towards north. This is the north and it is pointing towards north. South is pointing towards south. And this is the second case, when the magnet's south pole is towards north and magnet north pole is towards geographic south. So in this you can say, if we'll try to get the neutral points direction, we'll always get the neutral points in the same direction, that is north and south. We'll try to see magnet's magnetic field that you will get in this direction, magnet's magnetic field in this direction, in downward direction, okay, and Earth's magnetic field will be in upward direction. So both will cancel each other, just like this case. Here also magnetic field direction was just opposite to the direction of magnetic field of Earth. So both will cancel. Neutral points. So neutral points are at the points at which two magnetic fields are equal in magnitude. Which two magnetic field? One is of Earth and one is of bar magnet, but opposite in direction. So net magnetic field at a neutral point is 0. A compass needle, if placed at the neutral point, will rest in any direction. Okay, so these are the important points. Just read the theory properly, and then it will also be a kind of evidence, and you will also come to know that why Earth magnetic field is also we are assumed to be focus on that because of the presence of the neutral points. This is also one kind of evidence. So this is about the magnetism concept. This B part, electromagnet and its uses, that is not in the syllabus. Due to COVID it is curtailed from the syllabus. Just focus only till A part. And one more video I will post, that is on the basis of this C part of 9th chapter, this one. In next video, in 46 video, efficient use of energy, that you will get in that video, and the numericals of A and B exercise of current electricity. So just watch video again and again to get mastery. Okay, thank you very much.